Vertical roller mills, vrMs, are vital pieces of equipment in cement plants and are popular in new installations due to their high efficiency. However, technical issues with vrMs can be tricky to solve and may cause them to act as process bottlenecks. To comment on the possible sources of problems with vrMs. What are the sources of vibrations and how can we improve vrM lifespans? Firstly, as a rule, the root cause of vibrations in vrMs is always imbalanced forces and/or tension between the rollers and table. The causes of vibrations fit into four main categories. Mechanical aspects. 1. Check that the tightness of all screws for the roller, jack tensioning system, and drive units for the motor and gearbox are as stated by the manufacturer. 2. Control the height of dam ring, up or down, with respect to the main motor current. 3. Ensure suitable substrates and water injection control. 4. Check that accumulator pressure, bladder accumulator, or piston accumulator value is required. 5. Check the surface of table and rollers for spot pits, which can cause vibrations. 6. Prevent sources of oil contamination around the anchor bolts due to the potential for leaks around the hydraulic cylinder seals. 7. A high nitrogen pressure lowers the stiffness of the spring system, allowing for higher grinding working pressures. If operators have a higher nitrogen concentration to damper their high and low jump on the mill table, they should gradually increase the dam ring height and aim to fix the material size. Operators will notice that, once vibration levels stabilize, there is the potential to gradually increase the working pressure, thereby increasing the efficiency. 8. If the gear unit has been pulled out of mill, as in point 1 above, the base plate elevation should be checked to counter for any inclination in the foundations. B. Electrical aspects. Operators should ensure that the power supply to the vrM is steady and stable as variations in the voltage applied to the motor, in some cases, can result in a variation in the RPM. This can apply a positive or negative torque on the gearbox main shaft. There is also a friction force between the rollers and the table or material, which is transferred to the gearbox. Applying these two forces on the gearbox from the directions of input and output may result in negative dynamics that appear as vibrations. C. Production and process aspects. Operators should first ensure that the limestone granulometry adjacent to the main rollers is a maximum of 2,2400 m. Limestone size 100% passing should be 100 mm. In the event that the rollers are greater than 2,500 mm, one may have limestone where 100% passes 115 mm. If there are large chunks of limestone, there will be larger vibrations. Operators should 1. Check whether the raw materials have changed to ensure the correct feed size of incoming material. 2. Check that the raw mix is well mixed before feeding to mill. 3. Check the airflow across a mill, especially the pressure differential value through the mill. 4. Check good airflow in the classifier by opening guide vanes and check that there is a good seal on top. 5. Check the nozzles for moisture on the table. Clogged nozzles also give problems. Apply good water spray nozzles between and directed at the compressing side of feed near the roller crushing face. Avoid excess water spray. Bypassing of hot air also creates this problem. 6. Analyze reject closely to identify hard materials. 7. Check that the feed material size is not too fine or too coarse. More than 10–15% of such fine material does not allow for the formation of a good bed. 8. Check that the hydraulic motor for the separator is operating at a consistent speed. If there is a speed fault, the mill will not clear the fines, which will result in vibrations. 9. Check the moisture on the bed if mill and fan are stopped together and the mill is opened. This is a golden rule. The bed should be found to be well formed and moist, with around 3–4% moisture. The top of the bed should be 7–8% moisture. 10. Closely log the cleaning of the metal detector and separator and examine the material found therein. If the quantity is increasing, then some material is bypassing the separator and going to the mill. This would necessitate locating the entry point of these and, if that is a problem, increase the speed of the belt to reduce the belt material height. 11. Adjust the mill DP. For stable operation, before forcing the mill to maximum feed, ramp up the of capacity step by step to keep vibrations in check. D. Civil work aspects. Abnormal conditions that are related to civil works and foundation represent unlikely problems that might not be easy to solve. 1. Most mill foundations are multiple pours of concrete, which naturally gives rise to several cold joints. These cold joints do not allow the transfer of energy from one layer to the lower one, and thus the concrete is unable to perform its damping function properly. Oil contamination around the anchor bolts, which will eventually feed down into the cold joints, only compounds this problem. The other major problem is that the fastening of the gearbox and the mill stand itself is reliant on large steel structures embedded in the top pour of concrete. The interfaces between steel and concrete are vulnerable to oil penetration and the overall stability is immediately compromised. Any steel-concrete interface should require the use of epoxy grout to maintain a consistent integrity to the foundation, and provide a long trouble-free life. 2. Chalkfast layer is a new technology essential for large mills, that can play an important role in absorbing mill vibrations and maintain precise equipment alignment. Chalkfast works in collaboration with the anchoring system to maintain the aligned position of the equipment needed for efficient performance. It provides resistance to downward and lateral loads that could otherwise act on the foundation. 3. If there is a foundation problem, it can be easily checked by checking the vibration levels from the top of the mill down to the foundation. If the amplitude is reducing and the frequency is increasing as we go towards the foundation, and there is a minimum amplitude and max frequency at the foundation bolts, then the foundations must be tackled. The best way is to stop the mill, make holes around the foundation and pump epoxy cement into the foundation until it overflows. It should be allowed to set as per the supplier recommendations and then the mill can be restarted. The foundation problem should be resolved, unless the below is unable to take the load. 4. Oil contamination is a big enemy of foundations, so the steel used must be oil-free. A single concrete pour is a must for the whole foundation. A similar mix should be used for all sides of the foundation or take the corners and fill towards the center, rapidly disengaging the air entrained. The target is to make a monolithic structure in the minimum possible time. Foundation steel rods are normally twisted and tied around the base frame, which is leveled to the nearest millimeter. Many times it is stress relieved before installation. Other factors and protocols of locking, fasteners with torque and alignments make a great influence in vibration transmissions to the foundations. The body fasteners of the mill body itself are sometimes the source of vibrations. A major issue often found is a mismatch in the locations of drill holes during assembly. Therefore, workshop assembly and match marking is a must. Using the correct type of gaskets is the best plan. Also important is to tension all bolts equally to avoid deformation. 5. Sometimes it is possible to increase the static mass of the mill by putting a bucket or several buckets of grinding balls on the floor separator walkway to reduce vibrations. This should only be attempted following consultation with experts. How to improve vrM lifespans. Several companies have developed sensors to monitor the performance of the drive unit through temperature measurements on bearings, oil pressures and torque measurements. This helps operators to become fully aware of what is happening inside the drive unit. The monitoring of torque vibration is vital in that it helps operators to understand how the drive unit reacts to different operating conditions. Critical operations can be diagnosed and overloading of the machine can be avoided. There are other records for main operating parameters of the system such as mill feed rate, inlet temperature, hydraulic pressure and water injection rate, pressure drop and other factors in relation to drive unit monitoring. These technologies are now applied effectively by many of the major companies to avoid unnecessary stoppages. If the main parameters are under control, operations errors can also be analyzed and machine operations streamlined further, enabling an increases in the lifetime of the vrM. This was my first article on Global Cement Magazine. December 2016.